So Docker Swarm, by its definition, is a native clustering tool for Docker containers that can be used to manage a cluster of Docker nodes as a single virtual system. Docker Swarm allows you to add or subtract container iterations as computing demands change. Pretty straightforward. So why Docker Swarm? A short answer is it's just easier. And this is what I'll demonstrate in this training session. So let's move right on. I know we're jumping in, but we're going to build. You should have already been familiar with how to install and run Docker on a machine. So we're going to build a Docker Swarm cluster from that end. With the end goal to be able to build and deploy an application in Jenkins, I wanted to go over rather quickly how we actually do that. First off, our setup. We have 3 virtual machines. I'm going to show you what that looks like. I run Proxmox here, and so I have this virtual machine 1 on one physical server, virtual machine 2 on another physical server, and virtual machine 3 on another physical server. Okay, so now they each have a gig of RAM. So if we just run a free -g, oops, you're going to show about a gig of RAM. Okay. There are 32 gig root volumes. There are 2 virtual CPUs. They're all running CentOS 7. KDump has been disabled, and we're about to disable SE Linux. This is not absolutely necessary, but it does make things simpler. So, oh, and by the way, we're running CentOS 7 with the latest patches. All right. There it is. Can't type. All right. Oh. I like Vim, so pause real quickly.
While we install that, because these are brand new fresh machines, we may find other packages that I need to install. And what that'll let us do is, let me work in a familiar and a happy environment. We'll pause a minute while these are installing. It's important to note here that the firewall is not disabled.
So here's an example of how I use Proxmox. You can see it's peaking out at about 285K of write speed. While we select Swarm 2, we saw peaks that are over a meg. So I know that doesn't sound like a lot, but it's enough to make this being a third the speed of throughput of this is making a huge difference. And let's check Swarm 3. Yeah, you can see that it's also not constrained like Swarm 1 is. Okay, it should be done by now. Lost my cursor here. Where'd it go? All right, no, not quite. Got a little bit too eager. Now, I could have just used Vi, but in the event that I want to use that utility for other things, I will. It's necessary to install it for that reason. Okay, so Vi is installed. Now, so we're going to change this from enforcing to disabled. Okay, just like that. Now, you can do a set SE bool and disable SE Linux, or you can just do a reboot. In this case, I'm just going to do a reboot. So, one is Swarm 02, 192.168.0.112 is Swarm 03. Okay, that's all you have to do. All right, so we're going to ping swarm 01, and indeed all three machines know what swarm 01 is. And this is a good way to test after you've made changes like this. Swarm 02, all three of them resolve swarm 02 correctly, and swarm 03. No reason for it not to. All right, through the screen here. So having done that, we already ran the updates, configured the Etsy host file. We set the host names. Now we're going to set up the Docker repo. So this is something you go to the Docker website to get. We're going to install Docker CE, which is Docker Community Edition, and we use this command for it. That's wget download docker.com Linux CentOS Docker CE-.repo, and the output of that file is going to be into Etsy Yum Repos Docker repo. So press enter real quick. Oops, guess what? Oh, wget wasn't installed. Now, I did a very minimal install on these Docker hosts. And that's just simply so that we'll end up, having to install literally every single dependency. That's good for training, but not so good for a demo. As you can see, that Swarm 01 is slow. I could actually migrate it onto a faster server. Let me try to do a live migration here. Let's migrate it to the third Proxmox server. Oh, I still have the local CD-ROM enabled, so I'm going to have to fix that. Use any media, hit OK. Now let's migrate this up, puppy. Proxmox 03. Migrate it. Let's see, that should give us a little bit. So you guys can follow what I'm doing here. Now, if you're ever interested in the details of how a migration works, it calls the CPU pause command, copies system RAM, and so it's very dependent on how much RAM you have. Notice it's actually counting by bytes here. So that migration completed, that live migration completed, still shows that it's in a migration transition. However, yeah, there you go. That was just a refresh and it updated. And it's now completely on the third server. So we'll move that, get that back out of the way. Oops, too many clicks. All right, and you'll notice that it's still live. I never lost my TCP connection to it. That's one of the fantastic things about virtualization nowadays. Anyway, so let's rerun the wget command. Notice the repo is there. And then we're going to just simply do a yum install Docker CE. So we're going to do a yum dash install dash y docker dash CE. Now, what this should do is this should do a complete install of everything we are going to need software-wise. Docker IO, the container, D, the whole 9 yards. Now, once you do this install, you still have to enable, don't forget to enable the service and to start the service. Okay. Just installing software isn't good enough. And they're separate steps because sometimes you want to install the yum command will install software that doesn't always run as a daemon. So this is going to run the Docker daemon. We're going to run a system control, start Docker. Notice that goes ahead and gets the Docker subsystem running on the machine, and system control enable Docker. What that'll do is, you notice it creates symlinks in the systemd command using systemd to automatically start the Docker service on reboot. So the next thing we're going to do is we're going to configure the firewall ports used by Docker Swarm. And I have, I'm not going to go through each individual port and what it's used for, but you'll recognize a couple of them in there, for example, 443 and 80. And this is just to allow us to have access to websites and stuff like that. All right, notice they've all been added. Those commands have run. And then what we're going to do is we're going to do a firewall command reload, which I'm not sure you have to do, but you should do as good best practice. And then system control restart Docker just to get Docker running again and make sure that it has access to everything it needs. Now, this is all we're going to do on all three machines at the same time at this time. We're going to switch into, we're going to get out of the multi-execution mode. We're going to switch into Swarm 01, and we're going to use it as our main node. Let me resize these so that you can read them all easier. Okay, so Swarm 01 is going to be our main node. So what you have to do is you run Docker Swarm init on that machine, and you'll notice we're using the advertised address of 192.168.0.110. That is the IP address for Swarm 01. And it should go with that. Okay, so this is now, there's a concept of system managers and workers. This is going to be set up as a system manager. Now, in this particular drill, we're going to set them all up as joined as managers. So in order to do that, we need to pull the token that it wants so we can see what the manager looks like. Notice these tokens are different. Okay, it's the same port. This is the service that Docker is running on. Obviously, it's one of the ones that we already cleared up, permitted with the firewall command, all right? So we're going to take this Docker Swarm join command. Well, first I want to do something for you. I'm going to do a Docker node ls, and that should show you that you have one node and it's ready and it's active and it's a leader and it's a manager and it's on Docker Engine 19.03.12. Okay, lots of good stuff there. And that's just a random ID that's generated for that node. All right, now we're going to add the other two by running this command on the other nodes. Kind of cool. And now it's joined as a manager as well. Docker node ls. And you see Swarm 1 and Swarm 2 are both. Now, again, you can run them in worker nodes at all. So it's probably best practice to run a couple of manager nodes so that they can fail over, and then run all of your applications on worker nodes. And you can use, and you'll see that later on. Now we're going to do the same thing on Docker Swarm 3, and then Docker node ls will demonstrate again that we now have 3 nodes and they're all up and ready and they're talking to each other. So I was wondering how hard it is to set up a Docker Swarm. That's how you do it right there. So now what we're going to do is we're going to concentrate. It doesn't matter which one of these we use now, but I'm going to use Swarm 01. And what we're going to do is we're going to set up a simple service. Okay. And then we're going to just use an image that's out on that's out on Docker.io. Okay. So Docker service create, we're going to map port 80 to port 80. The name is web service. We're going to use 3 replicas, and it's called, we're going to pull this container, HTTPD. So what we should see is this. Now, what you're seeing during the preparation is that each node is going to go out and do a Docker pull and then start a container that's related to the web service of HTTPD. So you go, okay, so that's great. What's this deal with what is the service? Well, what's going to happen here is that we're actually starting a web service on each one of the nodes that you can reach from every single node. All right. This is what clustering is about. If you use this method, it will expose that port from each one of these containers, load balance, mind you, on every single node. So you can talk to any node in the service to reach this port for that service. All right. As you can see, this is progressing a little slowly. Again, this is we could have pre-pulled this, remember, from our Docker training. Could have pulled that image, and now we have 3 containers running, and the services converge. Now, what they mean by converge is they've mapped the ports. Now, what I want to do is we'll do a Docker service ls, and that'll show you what the service is. All right. And then you can do a Docker service PS, and the name is web service. And that should show you the services that are running on. Okay. Now keep in mind, and this is kind of cool, it automatically load balanced them on the 3 nodes. Okay. Let's see what we get when we hit one of the 3 nodes. Let me pull up a web browser here. All right. http://192.168.0.110. Remember, that's our Docker thing, and it works. Look at that. So that was really quickly how you do that, or how you set it up. Now, let me show you something cool. We can also hit 112, and it works. Oh, and yeah, Docker node 2 works as well. So that same service is being served on the same port on all 3 nodes. This is what I wanted to show you. Now, that's useful, but are you going to set up an individual load balancer for every single host and things like that? In other words, how do you get to the service? You know, you can just connect to it, but we also have the ability of using, oops, I shouldn't have closed that. Let's see what we got here. Oh, I wanted to demonstrate service scaling. I don't know if this is the right command because we haven't stopped the service, but what I'm going to do is I'm going to try and scale this service real quick. Docker service. So when you do the create, you can specify the number of replicas. Okay. Now, port 80 is already in use. So it thinks I'm trying to create the service instead of updating it. Don't think we need that. Update requires exactly one argument. Okay. Let me do a little bit of research because I should have been able to do this for you. I can do a Docker service RM web service like that, and that'll stop. You notice that web service is gone. Now, if I had done the create with 5 replicas, you'll notice. Now, watch how fast this runs. Remember, it took a while to start these guys and get them running before. This takes a whole lot less time because we've already pre-pulled the image. Remember I said that for a deployment, you can speed things up if you want to pre-stage an image by going ahead and doing a Docker pull first. So this is with the image already present on the machine. Okay, and now you actually see that there's 2 instances running on Swarm 1, and then 2 instances running on Swarm 3, and 1 instance running on Swarm 2. Okay. What we're going to do is we're going to say Docker service. I had this wrong, syntax wrong. Service scale. And what we're doing is it's actually, instead of, it doesn't restart or reload the ones that are already running. What it'll do is it'll just load the new instances. So that's the command we use, Docker service scale web service. Now, that's if you're getting poor performance and you think more instances of a service are going to help you out. So in our case, though, because it's a very simple service, I'm just going to scale it back to 3. You can see how quickly, even on a slow system like mine, how quickly the Docker makes these changes. So again, and you notice that it preserved the instance, one instance on each host, so as much load balance as possible. You can do an update. And what that'll do is that'll just, that could, if you, it doesn't do automatic load balancing in that if a machine fails and it restarts on another machine, you won't get that service. So this service is running, and what we're going to do is we're going to demonstrate the resiliency of this particular service. So let's say one of these guys dies. All right, Docker RM, and let's see, we get this node. There we go. That's the service, web service 1. A brain fart here. Give me a second, guys. RM. Oh, we'll just do it this way. Docker PS. Without that, it gives you by default the container that's actually running. This is at the Docker level. Yeah, we got to stop this before we can remove it. All right. Now we're going to do a Docker. And you'll note that you have this shutdown instance. This is the instance that I shut down manually, and that, but indeed, it's doing what it had to maintain 3 copies running. So that's pretty cool. Also, if these machines are rebooted or if one of them goes down, the manager gets reelected, and the manager service will determine whether or not to start that on another machine. So, Docker service RM web server or web service. Okay, so you're going to notice we don't have any services now. What I'm going to do next is, that's not very, that's great, and that's well and good, but I prefer to have something that's a little more useful. There's a product out called Traefik, Traefik. It's a load balancer that has auto config capabilities. So what we're going to do is we're going to install that service right now. And in our, by the way, in my DevOps repo, we have this script that I use. I'm going to copy and paste it in here. Okay. And We're going to edit that file. Shebang here, and let me copy and paste this in. So here's the script that I use, and we're going to go through this real quick. Docker, we're trying to do here is discover if the Docker networks, and we haven't talked about those yet. But what we're going to do is we're going to create an encrypted overlay network that is private to Traefik called Traefik Public. And you'll see why that's important. The host name is derived from the current host name. Okay, username and password, I put a random password here and here. This actually generates a hashed password, and it passes it so that when you log into the front end, it's set the same. Now, this publishes everything it can. Let me see here. That's good. And we'll even make HTTPS available and offload HTTPS from your services. Now, what we're going to do here is I'm going to make a quick change to this to make sure it is. You can see I already have some site from work in there. Into the local domain, so traefik.local. All right, then we'll set up a DNS point for that. All right, so it must run on a manager. So this is the Docker service create --name Traefik. We're going to publish port 80 and port 443. This is a DNS hostname rule that passes that says if you get this as the DNS name, we want to go to the front end. We're going to enable it. We're going to run it on Traefik runs internally on port 8080. And then the Docker network we're going to use is Traefik Public. This is the one we're creating up here with this piece of the script. And the front end auth basic users. So basically, it's going to be basic authentication with this user and this password. All right. We are going to, and this is, and we didn't get into volumes, so I'm going to talk a little bit about volumes here. This is a mount for the var run Docker socket, and what that does is that gives the instance of Traefik that is running access to the Docker socket to talk to the Docker daemon so that it can read labels. And it uses the labels, and I'll show you this later, uses the labels to determine what kind of service or what kind of load balancing to provide for a service. So if you put the right labels on a service after this is running, it will automatically load balance it. Yeah, I know, it's pretty amazing. We're going to use the Docker image for Traefik version 1.7, and then we're going to sell it. We're in form mode. We're telling the Docker domain it's going to be traefik.local. The API dashboard will be enabled, and it's supposed to watch the Docker socket, and we're going to do a web-based thing, and the entry point is going to be HTTP and HTTPS. All right, and then it's going to actually provide TLS, and I put a TLS minimum version of 1.2, and I set the log level to debug, of course. All right, any questions? I didn't think so. So we're going to save this. And then we're going to execute it. So what's it doing? Remember, it's pulling the image. And that's what takes the longest time. I could have done, again, I could have done that ahead of time, but I didn't. So now it's starting the image. Now, if there's something that's wrong, it'll bail out if you don't get a successful start. And then this waits for this. So Docker service OS. So you notice that Traefik is running. It is a replicated mode service, and it runs on port 80 and maps to internally port 80, and it runs on 443 and it maps to port 443. If you'll recall, I said that so what this means is the external port 80 is mapped to the internal port 80 on the Traefik container. Same thing with this. Now, these are going to be accessible from every single node in the system. All right. So if you hit port 80 on any of the nodes, you're going to be talking to Traefik, which will then load balance your containers for you. And I'll show you how that works in a little bit. But meanwhile, let's see. I'm going to need to do need to edit. Run this as administrator. You need administrative permissions to edit your host file. So I'm going to run this as the administrator. No, I don't want to update right now. Wait, wait for it. Okay, let me make sure there isn't anything that's not supposed to be in there, and see if I can't pull my local hosts file. Hosts, there it is. All right, so what we're going to do, you can see I already got one test host file in there. What we're going to do here is I'm going to say 10, or sorry, 192.168.0, any of the nodes. So we're going to load balance through 110, and we're going to call it traefik.local. Okay, let's save that. Now, if I go to a web browser, and I say HTTP, you should get, and you notice it redirected. Okay, it says the certificate's invalid because it's not, it's just the default certificate. Okay, excuse me. And we're going to go to Traefik local. Remember I said admin, and let me see, I can't remember. Oh, random password here. Yes, that's correct. What you're going to see is what this is actually a web service running on Docker. In what it's doing is it's allowing us to access the dashboard of the load balancer. And right now the only thing that's load balanced is traefik.local, and it's sent to, look at this weird address. Wonder how it got that. So that's the internal IP address and port of the container. Make sense? So it's mapping this port, port 80, to port 8080 on that container. And it does all of that for you. Okay? So let's make it even a little bit more useful. All right? And what we're going to do is, so managing all of this is great, right? But it's not so great when it comes to, you know, there are GUIs available. All right. So one of the things I'm going to do is I'm going to add another DNS entry in my local hosts file. We'll do that right now. Now, this is gonna look a little bit familiar to you. It looks the same, right? And we're gonna say, let's see, oh, Portainer. All right, I'm gonna save that. We'll push it to the background. And now, if I can get back to it, I'm gonna drop in another shell. And what we're gonna do is, so Portainer is a management system that uses agents on each one of the systems to take a peek at what's running on the system, and it gives you and it also has a central part, which is the web GUI itself. So I'm going to end up creating two files. So we're going to create build Portainer agent. Now I have cheated considerably because I have developed these scripts in the past, and I'm just dumping them into my current into this current config. So this thing, well, it's a little bit more painful than it looks usually when you're developing this stuff from scratch, but oh, let me see what we got here. Did something wrong. All right. It's because I highlighted it. Hold on. Hold one. So this is the script for the Portainer agent. And now it talks on port 9001. All right. And you'll notice that it also maps the Docker socket and the Docker volumes. This is so it has access to the volumes, and I'll show you what it needs. It just wants to, and the only constraint I've applied on this one is that I want it to be running on a Linux box. It has to run on a Linux box. So this is going to create a service named Portainer Agent, and it's going to create it's going to connect to the network called Portainer Agent Network. Wow. All right. So I check to see if it's existing. If it's not, then we do this create here. So, and it creates an encrypted attachable agent network. So let's save that. These things look real simple, don't they? Because they're not that hard. All right. So that's the creation of the network, and this is the actual Portainer agent. Now, we're running Portainer agent, let me see what it says. Yeah, latest. So all I have to do to update the service to the latest software or to any bug fixes or changes is just run an update to the service, and it will kill off the older containers and start new containers. All right, that looks pretty good. So let's build Portainer itself. All right, this one's going to be a little bit more interesting in that avoid creating that. Now this does exactly the same thing that the other ones did. If there is no volume for Portainer data, it creates the volume Portainer data. Now, let's talk about volumes. They are, you notice this says we want to store it on the EFS Portainer data volume. Now, we created that one as an EFS file system in AWS. So we can't obviously do that right now. I don't have a shared file system set up for this particular Docker instance. So what I'm going to do is I'm just going to put in, call it temp. Where is it? There we go. Where's my cursor? We're going to put it in temp for now. But what this means is once it's configured, and I'll show you what I mean by that, any data that it saves will only persist on that instance of Docker that it's running on. So if it changes and load balances, it will reinitialize the Portainer data. All right, so this is a bind mount for that. And then what we're going to do is we're going to go through this real quickly. This service runs on port 9000. Okay, so, and this is a label for the service that tells Traefik that. And then we put a label on the service that we're going to connect to Traefik public, which is the network I was talking about when we wanted to connect to Traefik. And then this rule is the one we're going to modify so that it uses the .local domain. Make sure that that's right. And then the back end is this is just the name for the back end. And this just says enable it. All right. Now this is going to want to run, and we also have to define that we're connecting to these particular networks. Remember, this one's already existing, this one, and this is the load balancer one, and this is the internal network that's encrypted that we're creating for this one. That we created with the Portainer agent. So it's going to connect to that network, talk to those instances of those containers so that it can pull information on individual hosts. It must run on a manager. We're going to map 9,000 to 9,000. That's straight. You notice up here we told Traefik that it's going to be running on 9,000. And then we're going to mount these again. It has a mount here that I'm going to change the temp. So this is the Portainer data. Now I need to set up a shared file system. I need to set up a shared file system to run this stuff. And you notice it wants access to the Docker socket as well. Okay. And then it's going to use the latest version of Portainer. All right, so let's actually run that and see what happens. I gotta change the mode. So, okay, so obviously I've screwed this up. Let me take a look and see what I did. Docker volume inspect Portainer. So that, let's see if that volume is. Yep, looks like it did create that Portainer. So this actually executed. Docker service create. I didn't like something that I did here. There's got to be a typo in here somewhere. Oh, here it is. Pretty straightforward. I didn't put the line continuation character on the end of this line when I edited it. Okay, let's try this again. Now, it should be harmless to run again, right? And Portainer is starting. Now, while this is starting, again, it's pulling the Portainer latest image. So it didn't. Now, you notice we're getting an error, invalid mount config. If you cancel out of this, Docker PS service, you'll notice that Portainer is running, but it's failing. So what we're going to do is Docker RM service Portainer. And the way you do that is right. Now, if I look at this again, I've cleaned it up. Now, what happened there? What caused me to indicate that? Well, it said something about the volume that didn't exist, volume or path not existing. So let's take a quick look. This volume, I'm pretty sure, didn't exist on the instance where it tried to create the image. That's the whole thing behind the shared volume thing. And it said it didn't exist. So what I could have done and should have done is just let it run, and it would have eventually tried to start it on one of the hosts that has that particular volume on it. I'm hoping. All right, that's not working. So we're going to kill it. Let's see. All right. we're going to disable this mount temporarily. And it's basically the same that wherever it'll pull that destination from inside the container instead of from external. So try that and see how that works. Ta-da. Okay. So what happened there? We don't have a shared file space set up for this particular cluster yet. Probably should have went through and done that, like through NFS or something. And then we didn't also set up the container or the volume in the correct place. But anyway, that should be running now. What we're going to do is I'm going to flip over, and you'll notice before I was able to actually flip over, there is a Portainer. There is now a Portainer service, and it's mapped to the backend Portainer, and that is running on port 9000 of this container. Let's see what that looks like. So let me create a new tab. There we go. And you notice it. I have this set up so it redirects automatically. So let's go proceed to portainer.local. And I'm going to put in, now this is what I meant by it saves data. It's going to save my password here. I'm just going to put in a password. And create that admin user. Now, I have to tell it what agents we're going to be using. So this is going to be my local or my home Docker. Okay. And see this? This is going to, this is a good example of more data that it's going to keep. But if you, we have multiple Portainer agents running on all the hosts. So I can say task.portainer agent 9001. And connect. Now, yeah, I misspelled that. All right. So anyway, we now have the Portainer UI up and working. All right. If you click on this, what we're now talking about is we have a way, and we're going to do the cluster visualizer. So this now, it provides your management interface for Docker Swarm. As you can see, all three of the Swarm hosts are represented here. And we're only going to display running tasks, but that doesn't matter. We don't have anything that's not running. So we have 1 gig of memory, 2 CPU, Swarm 01, so on, so on, so on. Now, looking at this, you can see that this agent, the Portainer agent, is running on each host. Portainer is actually running on Swarm 02, and Traefik is running on Swarm 01. So this makes it a bit more useful. Now, that's just the dash. Now, if we click back on the dashboard, it'll tell you how many stacks. Now, remember, we're not working with stacks yet. Stacks are represented and are used by the Docker Compose. So you can actually add a stack at this point from a Git repository. All right. You can add a service. And surprise, surprise, you can do that from a Git repository as well. And this is just showing examples. But here's a cool thing you can do now. This has a whole bunch of templates that you can just apply. So WordPress, CockroachDB, Iron Functions, you know, so on and so forth. The Datadog agent, for example. Okay, these are all created. Now, if I just click to show red container templates, I can stand up an individual container now, for example, MariaDB or MySQL, just by clicking on these and following the prompts. So this does make it much, much easier to deal with. And just for the rest of you, SQL Server Express, and then SQL Server Developer. This is for the Windows. This is a Windows container denoted by the Windows one. This is a Linux container denoted by the Linux command. So Solar, Redis, RabbitMQ. I mean, there's so many different things that they've already pre-configured for you to stand up if you want to. So this makes it a lot easier than doing a lot of the things that I've had to do by hand in the past. I do like this a lot. You don't see this at all with Kubernetes. Kubernetes doesn't really, there's a lot of predetermined templates out there that somebody wrote, but you have to always go through and modify them to make them work on your own. So let's take a look at the container view. So you can see we have Vortainer, and then .1, that's the iteration of the number of the container and that replicant, and then just a random ID. So that's the service. Then we have 3 Portainer agents, and here you can see they're running on 3 different hosts. And then we have Traefik again, which is running on Swarm. So that's pretty awesome. This also has image management in it, so you can look at all the images that you've used. You notice that we used HTTPD. All right, so if I set the filter to unused image, for example, that shows me what is taking up space image-wise on my servers that I'm not using. You notice it's 3 of them. That's because each one is on a different host. Swarm 1, 2, and 3. And because we did a replicated one, we had multiple instances running on each host. So I'm going to go ahead and select all of those and remove them. And what that does is that allows you to clean up some disk space, basically. You recall the Docker purge, or I think it's purge. I tell you, I do that differently every time. Docker purge command, that's kind of the equivalent of that. So here's networks. Now, it's interesting. You'll see an ingress network here. Okay. This is an overlay network that is used, and it's on all 3 of these hosts. So that's your ingress network. And then we have the host-based network, which is actually just how the host talks to the network. Then we have the Docker bridge and the system bridge. Now this, you notice they all have different subnet addressing. So you have to be careful when you stand this up to make sure that the subnets that you're using for, like, say, your ingress or your containers, which is what these subnets are for, do not conflict with resources that have to be connected to from within a container. So if a container is trying to talk to something in 172.17.0.1 and that's outside of your system, it's going to automatically connect to this network, the bridge network, and try to talk to it there. And of course, it will not be able to. Does that make sense? So let's look at the volumes we created. Remember the Portainer data volume we created? That's one of the things I was going to talk about quickly, is that you can actually look at stuff that's in a container or in a volume. Let me rephrase that. So if we wanted to browse, and this is a particular instance of something. Yes, okay, so you could actually see the files that are in it. And in some cases, if it's something that the web browser recognizes, you can actually just click on it and view it instead of downloading it. Configs, that's a little bit more advanced. What those are is those Docker configs. We don't use them too much. Secrets is cool. You can use create secrets to hide credentials and things like that from your system, or from configurations. That's what this is for. That's what the secrets is for. Swarm, obviously, this shows you the state of your swarm, tells you whether or not, it gives you the status of all these things. It tells you what version of the engine is, the IP addresses, whether it's ready and whether it's available. Okay, so that's basically your Docker node PS. Now, this is cool because it'll give you a total memory. It doesn't tell you what's actually used. It's your total CPUs and the Docker API version that's being used. But you can go to the cluster visualizer here again, and you've seen this before, and that'll show you graphically what is actually running on the system. There are extensions that you can buy, but they're pay for use, so you have to enter a license key. If here it's a you can set up users for this particular service. So I could set up a user for other teams or other developers, and then give them permission to come in here and use this cluster. So you can define your teams and your roles as separate ones. And then, of course, these are your endpoints. Let me fix that because that's bugging me for some reason. There we go. Update the endpoint. There you go. Now it just says, go to the endpoints, and we'll connect to this one. Well, that's interesting. There we go. That made it refresh. There was a bug where it was showing the old name up here. All right. Anyway, so that's an endpoint. Endpoint is actually, so you can manage multiple instances of Docker from this particular instance of Portainer. However, you have to have access to get to port 9001 on the nodes that you're talking to. That way you have Docker, you have your management containers running, your Docker Portainer agents running. Again, you can add groups, registries. We've not talked much about registries. I think the next step is going to be setting up a registry and pushing images to the registry and pulling images to the registry, because we're gonna need that to do development work. All right, I think that's enough for today, and I will talk to you guys later.